Here we are going to understand why starters are required in motors. Motors means, it means both AC and DC motors. For the sake of your understanding, I have taken a DC series motor schematic diagram here, and this is uniformly applicable to DC shunt motor, DC separately excited motor and induction motor. Concept is same for all these motors. Okay, so if you are asked this question, then the simple answer is the requirement of starter is for high starting current. Now the question generally arises, why the reason of this high starting current? So to get that answer, just apply a simple KVL law across the loop. So let us take the current that is coming out from the source Vs is IA. This is your KVL equation for this particular loop. From here, what is our objective? And what I have said earlier, I have mentioned the word or the phrase is high starting current. So we are going to determine the value of IA from this particular equation. Now here I have derived the value of IA or the armature current from this KVL equation. Now see, Vs is your source voltage, EB is your back EMF, and RAC and RA is your series coil resistance and armature resistance respectively. Now the value of EB depends upon which quantities. If we try to write the equation of EB, we get this equation, and the terms here NP, phi z and A are the speed, number of poles, flux. So here all those terms signifies the different things in DC motor. Now let us understand one thing. When the motor is going to start, because I have previously said about high starting current, so by that context, when it is going to start, does it have any speed? And the answer is, at the starting, speed is equal to 0. Reason? Because the motor is in stationary condition, it is not rotating, so the speed is obviously be 0. So when the speed is equal to 0, take this value n equal to 0 and putting it to this equation, what we get? We simply get EV is equal to 0. Now take this value EB is equal to 0 to our previous equation that we have derived earlier here. Now if we take this particular equation and name it as IA1, that is equal to Vs by RAC plus RA, or better to take it IAST, that means the starting current. Here I have put EB is equal to 0. Now at the running condition, the situation is different. Now if I write IA run, then the equation will be Vs minus EB divided by RA by RAC, that is identical with this equation that we have derived. Now compare both this equation. Let us name it equation number 1 and this is equation number 2. If we compare these two equations, then we get IAST is always greater than IA run? Yes or no? Because at the numerator part, EB is missing here. Okay, so if EB is missing here, and which is subtracted from the value of VS, then automatically starting current IAST is greater than running current. That is why the starting current is high in your motor, and we require starters to reduce this high current. Clear? And one thing you need to take it into your mind, you have to remember that when the motor is in running condition, then the value of the current does not remain as high as starting. Now you will ask why are you saying this? The answer I have already explained at this equation IA run. See, the running condition, you have to subtract the value of EB because N has a particular value. It's not equal to 0 at running condition. So when N has a particular value, then automatically the value of the running current will decrease and it will not be as same as the starting current. I think the entire concept is clear to you. If you have any confusions, then please do mention at the comment section below. Thank you.